where is our source and destination will indicate. This is source. The pilot wishes to travel from point X to point Y, and that too it is northeast. I think I cap J cap will not come. Am I right? So pilot will go for northeast, east of west. The natural direction conventions is what will be used by the pilot, not I cap J cap. Anywhere needed in calculations, we take help of I cap J cap. Agreed? This one. So this is the north. This is the east. This angle, it is given northeast. Okay, this is our source. This is the destination. The pilot moves from X to Y. His onward journey means from X to Y. His return journey means from Y to X. This much is there we have, and the distance XY is how much, length is in still air, a wind of 50 km blowing from the south, the pilot which will travel from point X to point Y. Yeah. It's 1,000 kilometer. Let me give XY here. I think 1,000 kilometers is a very in train it may take 1 day or 2 days. Okay, let's see that this aircraft, how much of time it will take to cover that. Now the distance from the source to destination is 1,000 kilometer. North of east is telling, so 45 degrees I put it. How the wind blows from the south. So we have 400 kilometer. What to do with that 400 kilometer? What it is? Aircraft flies at 400 kilometer in still air. So what shall I write? 400 kilometer. Anybody from student side? I want this. What shall I write?
With respect to
velocity of aircraft with respect to wind. Still what? Still air. Air will never be still. Am I right? Will be always blowing. So it's like with respect to still water, we said no. This is the thing. Velocity of wind 50 km per hour. Now the wind is blowing in this direction. From south means along north the wind is blowing. This is the velocity of wind. Okay, let's do one thing. Here let's rough diagram. Whether we are right or wrong, it will help us. The velocity of aircraft with respect to wind, let it be like this. The wind velocity. Now resultant, how it will come. This was our destination, no? So where do we will head now? We will reach somewhere here Z. So where we went wrong? Nothing wrong in thinking, but at least you should do correction. This was the source, this was destination, but we are adding at Z. This was our destination. Somewhere a place Z is what we are going to land. If I make velocity of aircraft with respect to wind, if it makes an angle 45 degrees. So how I should steer the plane? I should steer the plane in such a way that velocity of aircraft with respect to wind should be somewhere in this direction. The wind will push so that the effective velocity of the aircraft or the velocity of aircraft with respect to ground should be along path XY. Got it? This is very important, students. Nothing wrong, you think it, then at least you correct it. I had to show it's a wrong. No, sir, okay, at least show correct diagram, sir. Okay, I'll put it here. Now the velocity of aircraft, let it be directed here, VAW bar. Velocity of wind, it is blowing from south means along north. Now this will be the velocity of aircraft. This angle, I don't know, theta. This is alpha, this is theta. I don't know these things, but alpha plus theta is 45 degrees. What was our question asked? Calculate the time for his onward journey. So we should know VA here. Can we say anything about this angle? -45 degrees. Now we know VW, VAW. We know one of the angle. Somehow we should get VA. Now what is our question now? We have to calculate the VW, no? Here. Sorry, VA has to be determined. This angle I don't know. VA 450 kilometer per hour. I'm getting 433 somewhere. What has to be done? I think some. Can we go for? Is it a right angle triangle? Check it. No, it's not a right angle triangle. Beta. Can we say anything about beta? (2.52 hours). If VA changes, then VA different, then your answer will be different. Check one's calculation. So I'll go for sine rule. I'll apply sine rule. So from the sine rule, what I needed is VA by sine alpha should be equal to VAW by sine 45. VA by, so VW by sine alpha should be equal to VAW by cos 45. Alpha is unknown. I'll find out here. If I know alpha, then alpha plus beta plus 45 degrees equal to 180 degrees. I'll get the beta. From that, I'll go for again sine rule. VA sine beta is equal to VAW by sine 45. Or I'll write this sine rule, then all the unknown things you can find out. VA by sine beta.
Sir, can we say that VAW sine theta is equal to VW, sir?
No.
Why not?
Not why not? How come? See, the way.
Okay, no. Yes, sir. Understood, sir. How come? I understood wrong, sir. I understood very wrong.
Okay, now we have to, what are alpha, beta and VA? I think we can solve this. First using this combination, we'll get alpha. Okay, this. Then after getting alpha, substitute here, we'll get beta. That beta you substitute, you'll get VA. I have value, so you can cross check later on with for 433.7 kilometer per hour. This is the speed of VA. So now what is the onward journey from TA TXY should be equal to VA by thousand by 433.7. So 2.3 hours will take us. Within this time we are going to land there. Provided the pilot should be, he should have studied relative velocity. If you don't know relative velocity, gone. No question of landing at the destination. Got it? Now the return journey. This is the onward journey what we are discussing. Time taken for onward journey. Return journey we'll see. I will slide down. Yeah, we can draw a diagram here only. The return journey from y to x. First we'll have the basic diagram, because that is what going to help us a lot. So we are going to make a journey from y to x. There's a y, there's a x. The wind will blow. The wind will blow. So now how the velocity of aircraft with respect to wind. I think now we are a little bit very good in topic. The velocity of aircraft with respect to wind, let it be directed along the path. Then how the wind is blowing in this direction. So now the aircraft, the pilot should steer the aircraft in such a direction that so this angle is what we know, 45 degrees. This angle we don't know, let it be alpha. Now again we have to get into the calculation part. We should know VA, that's all. We have to calculate this VA. That alpha, this alpha are different. I'll bring some theta 1, alpha 1 or something. What are the things? VA is needed. No? So what about all other angles? How much this angle? Anybody? This angle is 45. This angle is 45. What can be this angle? 135?
135.
Yeah, it should be 135. I also improved a lot by teaching to you guys. Then the remaining angle, this we don't know, call beta 1. Let's get into again sine rule. VA by sine beta 1 equal to VAW by sine 135 degrees VW by sine alpha 1. We wanted VAW sine 135. So I'll get alpha 1, then alpha 1 plus beta 1. Now previously the pilots, they were supposed to do all this calculation. Just imagine. So now we have equipments to measure all these things. Previously what happened? Two co-pilots. Even till date it's continuing. Why the co-pilot was there means one of the pilot what happened used to give the parameters, the other what happened used to control the engine. They used to have pencil, eraser, so all these things. I think just you watch some movies, there are so nicely they have documented everything. Instead of watching our Telugu movies, no, I do suggest Telugu or Hindu movies or Kannada movies, no. You do watch some documentary movies like how they used to struggle all these calculations. Okay, now I'll end up the answer. I do have answer luckily for this question.
Sir, 135 degree.
Which
Yes,
one?
sir.
There
Alpha 1 plus
You
beta
wrote
1
145,
plus
sir.
130.
Oh, sorry. This is 135. $45 degrees?
degree.
No, I think we can manage. Anybody answer? TYX. 2.75 hour. Check later on. 2.75 hour. Let's get into okay, I agree this. I think some very good mathematics is there really. You have to put effort with the triangles, law, all that one, the relative velocity, everything you have to put it. So no, I think I delivered the thing which is needed. Velocity, aircraft, wind. Okay, there's a methodology is what you have to work out here. Write down first. We'll take the next type of questions. Better you have to see like this was the learning. Nothing wrong. Okay, well, if it is VAW bar is along XY, then where do the plane land? Plane will land at Z. So these are wrong. Okay, what should be the correct? The VA bar should be along the path. So everywhere in the problem you just indicate at least the right path with respect to ground. Path of whom? Path of aeroplane. Person standing on the ground should see that the plane is moving along y-axis. These things are not there in book, but I have seen in offline classes when I go around in the class, the students do write all these comments. Really, I really appreciate such students where they wanted to have a clarity. Such things is whatever you feel you understood, you can comment it. No, that's what your notes should be of that one. The notes should not be like what I scribbled. Along with this, your own understanding, your own effort should be reflected here. Provided you should put effort to understand, use brain in class, then only such comments can be written. No, otherwise just mere Cartoon Network. If you see how you write comments,